The next thing that we're going to be looking at are functional groups. So far we've just been looking mostly at carbons attached to carbons and then hydrogen surrounding them. What we're going to look at now is the part of a molecule that would not be carbon-carbon single bonds or carbon-hydrogen bonds. These are called functional groups. The functional groups identify a chemical group or a compound family that we might have. For instance, alcohols or ketones, that type thing. The functional group is very important because it gives it its physical and chemical characteristics. Oftentimes it is associated with smell or taste. The boiling point and the melting point are highly affected by the functional group, and color of compounds even comes from functional groups. They're the most important part of a molecule. Hydrocarbons are basically carbons that have only hydrogen and carbon in them, as it might be implied from the name. There are four different types of hydrocarbons. There are the alkanes, which are carbon-carbon compounds that have only carbon-carbon single bonds in them. There are hydrogens on all the carbons, but there are no functional groups on there, meaning there is nothing in there other than carbon-carbon single bonds and carbon-hydrogen bonds. There is a chemical class called the alkenes, which have carbon-carbon double bonds in them. Now there may be a huge number of carbon-carbon single bonds, but it is at least one carbon-carbon double bond. Now there's going to be hydrogens in there everywhere that are needed in order to make carbon have 4 bonds, but you'll have a carbon-carbon double bond in there somewhere. Alkynes have a carbon triple bond, and just like the alkenes, you can have a number of carbon single bonds in there, but there will be at least one carbon-carbon triple bond. And then last of all, we have the aromatic compounds. Aromatic compounds are those that have something called a benzene ring, which I have drawn here for you. It is a 6-carbon ring, and in that 6-carbon ring you have 3 double bonds spaced equally around. This is a very special ring. It has characteristics unlike any other, and that's why it gets this name aromatic. Aromatic has nothing to do with its smell. It's actually a misnomer. The first aromatic compounds did have a particular aroma with them, but since then we have a number of compounds that don't have the aromatic characteristic, but we call them aromatic compounds. There are a number of functional groups that have heteroatoms in them. These functional groups are probably the most important functional groups. These are the ones that we see in a lot of biochemicals. The first one we're going to look at are the alcohols. The alcohols are compounds that have an oxygen attached to a carbon, and then attached to the oxygen is a hydrogen. This oxygen-hydrogen group is called a hydroxyl group. The carbon, we're writing an R group there, but that's really a carbon chain there. That carbon can have either carbons or hydrogens attached to it, it doesn't matter, but it cannot have any heteroatom attached to that carbon other than the hydroxyl group. Ethers have a carbon-oxygen-carbon single bond arrangement. There can be no double bond in there. The carbons can have either carbons or hydrogens attached to them, but there can be no oxygens attached to those carbons other than the one in the center. Amines have a carbon-nitrogen bond in them, and The carbon can have no oxygen on it, but it can have either carbons or hydrogens attached to it. The nitrogen can either have two hydrogens on it, or it can have a hydrogen and another carbon bond on it, or three carbon bonds altogether on it. It can have no double bond on the nitrogen, no double bond on the carbon, no double bond to an oxygen on the carbon, or else it goes into a different functional group. If you have that nitrogen attached to the carbon, the nitrogen group is called an amino group. The most common amino group is to have it so that there are two hydrogens attached to the nitrogen. Here are some examples of those functional groups that we just discussed. Methanol has a carbon attached to an oxygen, and then to that oxygen is a hydrogen. It is an alcohol. There's a number of alcohols that we have. You've probably heard of ethanol, which is an alcohol, and it looks very much like methanol, except it has two carbons on it. The second compound is an ether, diethyl ether, and you can see there is a carbon attached to an oxygen, which is then attached to a carbon. And if you count bonds, you would find those are all single bonds. Those hydrogens that are attached to the first carbon are not attached to the oxygen. Remember, hydrogens are attached to the atom that they follow. So this oxygen does not have any hydrogens attached to it, only the two carbons. If we look at the next compound, we can see there is a carbon attached to a nitrogen, and then the nitrogen has two hydrogens attached to it. This is an example of an amine, and the name of this is methylamine. There are some carbon compounds that have carbon-oxygen double bonds in them. These are called carbonyl groups. Just as we called an oxygen-hydrogen group a hydroxyl group, and a nitrogen-hydrogen group an amino group, we can call this carbon-oxygen double bond a carbonyl. We find a lot of carbonyls in our functional groups. We're going to be seeing it. Two functional groups that have carbonyls in them are aldehydes and ketones. Remember that R means any carbon chain. What we see in aldehydes is at the end of a carbon chain, you have a carbonyl, and then a hydrogen attached to that carbonyl. So aldehydes have this carbon-oxygen functional group with a hydrogen attached to it. Ketones are very similar to aldehydes, but instead of having a hydrogen attached to the carbon in the carbonyl, you actually have two carbon chains. One way of looking at aldehydes and ketones is that they're very similar to each other. It's just that aldehydes have their functional group on the end of a chain, and ketones have their functional group in the middle of a chain. Here are three more examples of functional groups that have carbonyls in them. The one at the top, these are carboxylic acids. Carboxylic acids basically are carbonyls with a hydroxyl group attached to them. So the carbon has a double bond to an oxygen and then a single bond to an oxygen with a hydrogen attached. Esters look a lot like carboxylic acids. The difference between a carboxylic acid and an ester is instead of a hydrogen being attached to that oxygen that is singly bound to carbon, there is a carbon chain attached to it. Amides are like carboxylic acids in that instead of having a hydroxyl group attached to the carbonyl, there's an amino group there. Here are some examples. You can see there's a carbonyl at the end of the chain with a hydrogen attached to the carbonyl, so it's an aldehyde. This particular aldehyde has the name propanal. Here we have a carbonyl that is in the middle of a chain, so this is a ketone. This ketone has the name acetone. It's also called propanone. This bottom compound is a carboxylic acid. We can recognize it's a carboxylic acid because the carbonyl has a hydroxyl group attached to it. This particular carboxylic acid is called acetic acid. We've seen this before when we were in our acid and base chapter, and it behaved as an acid there, and it is an acid. That's why it has the name acetic acid, and anything with this carbonyl and hydroxyl group attached to a carbonyl is also an acid. Here is an example of an ester and an amide. The ester looks like a carboxylic acid, but you can see there's a carbon chain there instead of a hydrogen attached to the oxygen that is singly bound to the carbon. So this particular ester is called ethyl acetate because it has an ethyl group attached to that oxygen. If I look at the bottom compound, an amide, it looks like a carboxylic acid, but instead of having a hydroxyl group attached to the carbonyl, we've got an amino group. This particular compound is called acetamide, and we can recognize it as being an amide and not an amine because of the carbonyl on that nitrogen. Don't get confused. These functional groups can be really confusing, and I know that right now you probably feel overwhelmed, but you will be able to organize this material and you will be able to start making sense of it. Right now it's very confusing. I'm going to try and point out something so as to help you sort through all these hydrogens and oxygens and double bonds and all that, because it can get very confusing. We've seen the hydroxyl group, and we've seen that it is on both alcohols and on carboxylic acids. So as soon as you see a hydroxyl group, don't think that it's necessarily an alcohol. Check and make sure that the carbon to which the hydroxyl group is attached does not have a carbonyl. If it does not have a carbonyl, as in methanol, then you know it's an alcohol. But if it does have a carbonyl there, then you know you've got a carboxylic acid. You can see an oxygen attached to a carbon chain in both esters and ethers, and those two names are very similar, and I see students mix the two up a lot because their names are so similar. So be careful of those names. If I look at how esters and ethers are similar, as you can see, there's an oxygen with a carbon chain on either side. But in an ether, there's no carbonyl. In an ester, you've got a carbonyl in there. Nitrogen is in both amines and in amides. And you can see it would be easy to confuse them because there's an H2 in either of them. But in an amine, there's no carbonyl. In an amide, there is a carbonyl.